Now we're going to take a look at how to construct a confidence interval for the difference of two proportions. So we're going to have something like this. I have two proportions, one in each sample, and I'm going to look at the population proportions and estimate their difference. So P1 minus P2. I want the difference between these two population proportions. So when we build our interval, we're going to have something like this. A is less than the difference, which in turn is less than B. We just need to compute the A and the B. Here's what our formula is going to look like. Now I'm just going to do it as the difference plus or minus an error. So we're going to have the difference. Now the difference is going to be this. It's going to be P1 hat. Remember what hat was? The hat was the estimated proportion. So you take the number you observe, the number that you observe, and divide by the total number of observations. So that's going to be an estimate for the proportion in the first sample minus P2 hat, an estimate for the population proportion in the second sample, and then plus or minus some error. Now let's write that error formula. So it's P1 hat minus P2 hat plus or minus, now here's how this formula goes. It's a Z formula, Z sub C. It turns out proportions are normally distributed when, remember, NP and NQ are greater than 5. So we're going to get our critical value, and then we're going to multiply it by this square root. It looks like this. It's P1 hat, Q1 hat, all over N1, and then plus P2 hat, the estimated value of that proportion, Q2 hat, all over N2. Here's what all these values are. P1 hat, you take the number of successes that you have in your first sample, divided by the total number in the sample. Same thing for P2 hat. P2 hat is equal to the number of successes you see in your second sample divided by that sample size. And we're going to assume when we use this that all of these N1 P1 hat is greater than 5. N1 Q1 hat is greater than 5. N2 P2 hat, that's greater than 5. N2 Q2 hat is greater than 5. All right, if all those conditions are met, that gives us a pretty good normal curve for population proportions. Here's an example. Now I'm going to do it two ways. I'm going to do it first, just entering the data in on my calculator, and then if you want to stick around and see how I do it by, pencil by all the substitutions in arithmetic, you can do that. But calculator first, arithmetic second. Let's see what we've got here. Myers and Briggs dealing with marriage counseling. Most married couples have 2 or 3 personality preferences in common. Myers used a random sample of 375 married couples and found that 132 of them had 3 preferences in common. Then another random sample of 571 couples showed that 217 had 2 personality preferences in common. What we want to do is find let's call it a 90% confidence interval for the actual difference between the two proportions. Let's summarize our information. So we've got 2 samples. I call them N1 and N2. N1, all right, that's maybe the first sample of 375. So that's 375. And N2, right, N2, that's the sample size of the second sample, 571. And in the first sample, what do we see? Right up here, 132 had 3 preferences in common. So that's our R1. The number of successes we see, R1, and apparently successes are having something in common. So R1 is 132. R2, the number of successes we see over here is, where do we see this? There it is, 217 preferences in common. Now let's go ahead and get P1 and Q1. All right, P1 is going to be R1 over N1, and that is, what do we get here? 132 over 375. So I got P1 on my calculator. I'm getting 0.352. 0.352. So about 35.2% of married couples have 3 common personality preferences. Now what about the second sample? So P2, now these are actually hats, right? These are our estimates. So P2 hat is, right, 217 we observe with this characteristic over 571. So P2 hat, right, that is 0.380. So about 38% of people have, married couples have 2 preferences in common. Now, just out of curiosity, what is this? What is P1 hat minus Q1 hat? All right, well, that's going to be 0.352 minus 0.380, and that gives me 0.028, but negative. You know what? I just want to know the difference. I'll take the absolute value. I don't care if it's positive or negative. So there's about a 2.8% difference in our observations. Let's get a confidence interval for the actual difference. Now I'm just going to go straight to the calculator. So on the calculator, maybe we know where to go now. I'm going to type in, I'm going to press the stat key. All right, so I press stat, and then I arrow over to tests. And then, once I get to tests, I'm going to scroll down to, all right, it's quite a ways down. It's B. Scroll down to B, and B says 2 prop proportion Z interval. Z interval. And you can see in the formula we're using a Z interval because the formula involves a Z. Now you select Z, and now it's just asking you to put in these numbers. So how about this? X1, all right, that's our number of observations out of sample 1, that was 132, and N1, all right, that was 375. X2 is 217. N2 is 571. And now sea level, or I think we decided to do this at 90%. So I'm just going to put in 90, put in 0.90 if you like, and then go down and calculate. Now when you press calculate, reflect on this, that somebody programmed all of this into your calculator just to make life so much easier on us. So enjoy it. So it comes out now to this interval here. So it's giving it in interval notation. So we're getting negative 0.08. I'm just going to round off. Negative 0.08. And then up to positive 0.02. You know what? I'll go to another decimal place. 0.81 to 0.024. Now that's okay, but you might write it like this. Negative 0.081, 081 is less than P1 minus P2. Let me write that readable. Less than 0.024. That would work. Or you might even want to do this. Negative 0.081 less than P. Now what is P1? P is the people, the married couples who have 3 personality preferences in common. So maybe I could write a 3 here. Minus, and then what is P sub 2? Well, that turns out to be the proportion having 2. So I'll just write a 2 less than 0.024. Now the 3 and the 2 just remind me, okay, that's 3 preferences, 2 preferences. So I like this one because it tells you what it is. And notice again that we've got 0. 0 is included in this interval. So that tells us that there's a 90% chance, because we did this at 90%, remember, there's a 90% chance that there's no difference in these two proportions. Now, if you want to stick around, I'm going to actually do this where I substitute the numbers in and compute, although I'll do a brief version of that. Here's our formula, and we computed already, right, just out of curiosity. We got P1 hat and P2 hat. So what we got was this. We got 0.352 minus 0.380 plus or minus. Now, you remember the z-score at 90%. That was 1.64 or 1.65 or 1.645. You can use either one. Times, okay, now P1 hat. P1 hat is 0.352 times Q1 hat. Now, P1, here's, you have P1, and then Q1 hat is 1 minus P1 hat. So if we don't want to do any computations any more than we have to, I could just write this, 1 minus 0.352, or you can just go ahead and do that. All right, there's P1 hat, Q1 hat, all divided by N1, and N1 was our sample size there, and that was 375. Plus, here's where I am, P2 hat, all right, P2 hat was 0.380, and then 1 minus 0.380 to get Q hat, all over, here's where we are, all over N2, and N2 is 571. Here's what I'm put on my calculator. I'm going to type in parentheses 0.352 minus 0.380, and then I'm going to put in, now I can't do both plus and minus at the same time. I'll just do a minus, and then I'll come back and get the plus. So it's going to be 1.64, and then press the square root key. Now you've got some operations here. I'm going to put it in just as I see it. 0.352 times 1 minus 0.352 divided by 375 plus 0.380 parentheses 1 minus 0.380 close, divide that by 571. Now as you do that on your calculator, that square root goes all the way across. And my calculator shows negative 0.08039. So if I round that off, it's going to be negative 0.08, and then I could just leave it as 0. Now that's less than P1 minus P2 is less than. On your calculator, type in this. Press second, and then down at the bottom right, press the Enter key. And right above the Enter key it says Entry. And what it does, it brings back the last thing that you entered. So the last thing you entered was all this, right? You did it with a minus sign. So just press second, Entry. It brings the whole thing back. Now just scroll over to that minus sign. All right, so scroll to the minus. And type plus. All right, so just change it from a minus to a plus, and then press Enter. Now when you press Enter, we're getting the other interval, which is 0.02, I'll round off, 024. So what did we get before? Now I'm getting 0.080 to 0.024. Now let me just check back here. I'm going to go back a page. There it is. Well, 0.081 to 024. All right, so a little bit of rounding because we use the Z table here, and the Z table rounds off. So doing it on the calculator, just entering the numbers like this, just doing it like this is more accurate than doing it by hand because there's a lot of ways to make a mistake by hand, and also we're rounding off. So here's a question. If somebody claims that there's a 10% difference in the proportions, what would you say? So look at your confidence interval. Your confidence interval is going from negative 8% up to 2.4%. Where's 10%? Right, 10%, well 10%, right, 10% is way out here. Right, that's not in your confidence interval. You're 90% sure that this interval captures the true difference. A 10% difference, well, that's way out here. So we would say, no, we have statistical evidence to show that 10%, the difference is not 10%. So I'll even say it up here. It said, here's what I would say. We reject that claim as we have statistical evidence that the difference is less than 10%.